This lesson on scientific notation is one of my favorite lessons. I found this lesson online and changed it to make it my own, but there's some really cool stuff in it, so that's why you'll notice it looks a little bit different than the other lessons you've seen. So the first thing that we're going to write about scientific notation will be on the next page. I don't need you to copy down anything from this page, but for scientific notation, we need to understand what this means. This is actually two inequalities, and it's called a compound inequality. In order to find values that will work when we're talking about scientific notation, we need to choose numbers that are greater than or equal to 1. So 1 is okay. And anything greater than 1 is okay, as long as it is also less than 10. So notice here, 10 is not okay. So I'm looking for numbers that are between 1 and 10. So I'm going to go through the rest of these really quickly and cross out the numbers that are okay, or excuse me, cross out the numbers that are wrong and circle the numbers that are okay. This number is okay because it's between 1 and 10. It's 6. This number is okay because it's also between 1 and 10. It's 9.997. This number is okay. It's between 1 and 10. It's 5.98. Now this number is not okay. It's too small. It's less than 1. This number is not okay because it's too big. It's greater than 10. This number, not okay. It's too small. It's less than 1. This number, not okay. Too big. It's bigger than 10. And this is the last number on this page that is okay. It's between 1 and 10. It's about 2. This is something we're going to do in class that I will have people come up to the board and try this. What you're going to do is decide, just like I did on the last page, which of these numbers are correct. So again, we're looking for numbers that are between 1 and 10. Is this number between 1 and 10? No. What if I tried this number? Is this number between 1 and 10? Yes, it is, but I'm going to go ahead and put it in here, and it spits it back out. It shows me that that's definitely wrong. Tomorrow in class, we will try this out. So here's the reason that we will need to use scientific notation. Scientific notation is used to represent numbers that are either very large or very small. If you were writing a report for Miss Helwig that talked about the size of the Earth, you would not want to write this number over and over and over again. This is even on a computer where you get to type all these zeros. This takes a very long time to type or write. So we're going to learn how to write this in a much shorter way because this number is just way too large to write out. So here's the first thing that we're going to write down. How do we write numbers in scientific notation? Well, we've already talked about this first number. This first number is very special. It needs to be between 1 and 10. And remember, 10 is not okay, but 1 is. So we're going to have a number here that will have a decimal in it, and it's going to be multiplied by 10 to some power. We'll have an exponent here. So here are some examples of these numbers. 2.0, this works. It's between 1 and 10, and it's times 10 to the 4th power. Here's another example, 1.06. This is a good first number. It's between 1 and 10, and then it's multiplied by 10 to the negative 7. Here's a final example. The first number is good. It's between 1 and 10, and I've got times by 10 to the 12th. So these are just examples of what scientific notation looks like. Here is a test to see if we understand what numbers are okay to be in the front. So let's look at these. Some of these are correctly written and some are not. Look at this first number. Is this between 1 and 10? Yes, this is correctly written. What about this first number? 16 between 1 and 10? No, it's not. What about this first number? Is this between 1 and 10? Nope. So that's incorrect. What about this number? Is this between 1 and 10? Yes, it is. So now we can practice actually writing what scientific notation looks like. Here's a number. It's too big for me to write, so I'm going to change it to scientific notation. Scientific notation is some number times 10 to a power. The first question I'm going to ask myself, is this a very large number or a very small number? Well, this is a very large number, which means that my exponent up here will be positive. I have to put my decimal in here somewhere. If I put the decimal here, I've made the number 895,000. I know that's not right because I'm looking to make a number that's between 1 and 10. Where is the only place that I can put the decimal? Right here, between the 8 and the 9 and the 5. 8.95. Now there's a bunch of zeros back here. There's as many as I need there to be. And in order to figure out the power here, we're going to count from this decimal until the end of the number. How many numbers are in between? 1, 2, 3, 4, 5, 6, 7, 8. The exponent will be 8. So in scientific notation, this very large number would be written 8.95 times 10 to the 8th. If I pick this up and slide this over, I can check my answer. That's correct. Let's try this next one. Is this a very large number or a very small number? It's a very small number. You can see that it's very much less than 1. So this is going to have a negative exponent on it. That's how it becomes a small number. And now I need to put my decimal point somewhere in here that will make a number between 1 and 10. The only place it can go is right there. 6.73. Now I need to count. How many digits are there between these two decimal points? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 digits there. And I can check my work. I'm going to drag this over here, see if we're correct. And we are. 6.73 times 10 to the negative 9. 2 more questions here that I would like you to try. Have those done on your notes for tomorrow. And on this next page, we're going to go the opposite direction. Now I'm being given a number in scientific notation, and I'm going to turn it into either a very large number or a very small number. This 10 to the 5th power tells me I'm going to be making a very large number. So I'm going to write my 9.8. And this 5 tells me how many times to move my decimal. 1, 2, 3, 4, 5. There's my new decimal. I need to fill these in with zeros. Now this is really sloppy. So I'm going to rewrite my answer so that it's easy to see. 9, 8 with 4 zeros behind it. Put my commas where they belong. The answer is 980,000. Let's go ahead and check that. There it is. Let's try this next one. 10 to the negative 8. Now that doesn't mean my answer is going to be negative. This tells me that it's going to be a very small answer. So I'm going to write my 1.34. And this tells me how many times to move. I'm going to move 8 times, but this time I'm making a small number, so I'm going to be moving to the left. 1, 2, 3, 4, 5, 6, 7, 8 times. Look at all these zeros that I'm going to have to fill in. And again, this is super messy. I'm going to rewrite it, and then I'm going to check my answer. My answer is 0.00000. 0, 1, 2, 3, 4, 5, 6, 7 of them, followed by a 1, 3, 4. Let's check our answer to see if this is correct. Look underneath here. We've got 1, 2, 3, 4, 5, 6, 7, and my 1, 3, 4. The next page, sorry, let me go back. I'd like you to finish these other two problems on your notes. And this final page is a place you can go to play a scientific notation game. When you get to the website, you'll see review lesson first. You can scroll down to where it says play a game, and you'll click on countdown. It's going to see how many questions you can answer correctly in 1 minute. The website is tinyurl.com/carnessn, which stands for scientific notation.